Speech is still very complicated. Music is simpler.
To be or not to be? That is the question.
Only by computer could they be calculated and for the first time pictorially described. The entire musical score accompanying this film was composed on a computer that can produce nearly endless variations of sounds.
I am checking. Kindly wait.
You know what they say. No good deed goes unpunished. If you didn't want the answer, you shouldn't have asked the question.
The most logical course of action is to transport me to safety with all due urgency.
Howdy do. Welcome to another go at it. Another one. Why not have another one? Right, so number 6. Number 6, you were only supposed to blow the bleep 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 doors off. K40 upgrade case. Okay, so I noticed a big error. That bit there is round the wrong way. Plus I didn't finish off the hole. So sort that out. I've had an idea overnight about the case. So I'm going to explore those ideas now. So let's get on with it.
My interpretation of the data leaves little room for error. That is better. Our relationship will be best served if your statements are free of ambiguity.
To it. Right, so we've got this here. Now, I did think of some stuff, I wanted to do. Right, so, because we've cut it in half to make space for this runner, and this one. So basically I was thinking, what about if we don't cut the case in half? How about we don't cut it in half? And how about we just cut a piece out here? So we cut a piece out just to fit a slot to fit that runner. So you got your clearance on top, 20mm, and then your clearance on the bottom. And then we can leave the rest of it intact. Now the only thing we won't achieve is a pass-through. Material pass-through. So, but we probably could do something about that in the future, unless we cut it out ready for now. So we cut out, while we're cutting out the sides, because obviously we'll have to cut this piece out. Whether we cut this out as well and maybe hinge it or something like that, front and back. So we cut it in half. Yeah, we cut it in half. We can always bolt, instead of having the angle, we could always bolt it on. But if we cut it in half, yeah, so probably you would have to model it and work out. We've got to work out the focal length as well. There's lots to work out at the minute. Loads of people on YouTube have done all sorts of things with these. So, but I was thinking if we could bolt the bottom back either do similar to what we're doing there with the angle, but to save the angle we could probably just not cut it out all the way. So we have a material pass through to a certain degree. The carriage wheel here can't come all the way over anyway, because the let me just take the lid off. Hang on, take the lid off. Right, and then the tube angle. Right. So if you can't come all the way over because you've got the laser at the front. So as long as that laser can get all the way over to this bit here, it's doing its job. So the carriage wheel is behind by a bit. So that bit that it's behind, once that's all the way over here, I'll tell you what, let's just move it over here. Once that's over here as far as we dare take it, something like that. You see, that's even too far, it's over the case. So you basically need to just drop it back a bit. That's probably as far as it's going to come, like that. So you've got all this space here. So basically we could cut the case, we put the upper case back again. Instead of cutting it there, we need to cut, say, from there to there, but only where as far as the carriage runs. So we could leave the corners intact, so we don't actually cut the whole thing in half. So we leave that corner on and this corner about there, and we do it all the way around, so it's still one complete box or case. We do the same this side. So basically we only cut out with the grinder we slit across down like a letterbox type of thing. And the same here for material pass through. The same at the back, and so all the sides and back we have a material pass through, and the sides will be, we only need sort of 30mm. So take the upper off again. Right, let's just put it into a different mode so we can just see it a bit clearer. Right, I don't know if that's clearer, but this bit here, the hood, excuse me, the hood sits above there and down, and this moves across it. So that's 20mm. So we want 5mm above, 5mm below clearance in the case. So the case upper. So we can leave the corners intact. That's what I'm saying, like that. So we could lose then the angle. We don't need the angle. And we could fasten the gantry still to the corners. So we could fasten the gantry there. So a couple of bolts there, and a couple this side, a couple there, and a couple there. So basically that's what I was thinking. And that way we keep the bottom and the space in. And then we can have a pass through still, and then we can still catch all the bits, and it'll still be about that size on the table. So yeah, rather than look like, hang on, like that, you maintain it basically. And you could probably you might be able to keep your power supply in there as well. You might be able to keep your power supply, but at the minute that's all the way down. I've got to go measure again the case from top to bottom, because I have messed around with the sizes when I cut it. But basically I could lose the angle then. I don't need the angle, so we don't have to cut the whole case. You get your angle grinder with a slitting disc, you mark it out, you cut the case pieces out, and you slot this and to hold the gantry still, or you bolt it to these uprights. Now you could, if you wanted to as well. You know, you couldn't do it there, could you? You couldn't lose that motor. As I say, you could put the motor inside here, but no, you couldn't. Not the way it is, because you haven't got the clearance. So I'll leave it on the outside. That way you get the maximum cutting area. And so anyway, we need to do some more modelling. We need to model the power supply. We need to model the tube as well. Tube angle. So we could do with modelling the tube, but you don't really need the tube, but we could do with modelling it and any other holes that are in it. But I reckon then we wouldn't need these bits. We wouldn't need the stands. We could just make them square or just put metal brackets on. Yeah, you could do it other ways. Basically, just drill that through and bolt it through. So yeah, they just, where that fixing goes in there, they drill a hole here and then they fasten it through into there. So there's that way of doing it. Just notice that fixing's not out there, isn't it? Look at that. It's not in the right position. So I don't know why that's not in the right position, but it's out by a bit. Let's see if we can get it in the right position. Not quite. That's 1 mil. So 0.5. No, that's too much. What happened there? It's like the hole's not right, isn't it? Oh, it's probably the hole in the plastic. It's not right. It's weird. Strange goings on there. Okay, so I'll tell you the easiest way is to delete them two. Yeah, they're not quite right there. I don't know what happened there. Let's try it. Let's grab 2 more of them. We know it's 20 mil apart. I'll just go 20 mil. I think that's what I did before. Now they are. So that's something weird going on there. So it's in the right place, but I must have moved something. Let's have a look at these the same. No, these are okay. Right, so let's just measure the distance there. Let's just get this right. Two mil. Okay. 2 millimeters. Let's just measure that. 0.74. So the best thing we can do is to grab all this and move it down. Move it down temporary to there, and move it up 2 millimeters. Right, and hopefully they'll all line up again now. Hopefully, I don't know what happened there, but anyway. Yeah, so they line up now. That's good. Right, okay, so I've sorted that out. Now, is it going to be the same over this side? No, that one's okay. What about round the back? I must have selected something when I was... Yeah, it looks okay there. Right, so it is okay now. Anyway, we could leave those feet on it. It doesn't hurt. It just looks weird. I suppose if you ever wanted to take it apart, but it is... what I don't want to do really is provide angles when we don't need it. If we can use the structure, if we can just use the structure of it, what we've got already, and just bolt it to the case, It's going to be flush with that anyway, look. So we might as well just bolt it straight through and only cut out the bits we need. There's less cutting out and less mess. Let me just make sure we've got audio.
Just use the structure of it.
Yeah, we've got audio. I didn't put a comment in yet, have I? Forgot to put a comment in. Anyway. Yeah, so let's sort out some other bits first. Let's just save that. Right, so I've got to sort out this bit. We haven't quite finished this bit here. This is the wrong way round, I just noticed today. I noticed it while looking at it. So I've got to get hold of that. Can I just flip along the red? I can, but it's gone a bit wonky, so undo the flip. So I'll just do it from the other way, underneath. Do it from the underneath and just turn it. Alright, let's do it from there. So I'll do that and just turn it round like that. Okay, so it should be the right way up now. Yeah, that's the right way out because it has to shine through. Shines through. Shines off this mirror into the hole for that. But we haven't got a hole in it, so oh, what have I done? No, that's right, yeah. So I've got to create a hole in that now. Still got the same one here, so I can measure it. Let me just measure. There was a hole missing to let the beam go through. Right, so it looks like from the, so it's about 8 mil. The diameter of the hole is 10 mil. So you go 8 mil up and do a 10 mil hole, and that should give us a 10 mil at the top. Right, let's do that. Let's do that now. So let's get hold of this. Okay, let's just bring it up there. We want just to, we've got to find the center point, which is that point there. So I'll put a temporary line on it. That's the center point. Let's measure. Well, it's 10 mil from the top, and it's also 7 or 8 mil from the bottom. Now, is that 10 mil diameter? 9.5. So that one wasn't 8 mil, it was 7.5. Right, so we can put now a what we want is that's 10 mil, so we want 5 mil marker, and we need a problem now. We need to make sure we got the right. That's it. So we start from there and we go. It's 10 mil, so we do 5 mil. That's it. Now we can get rid of the geometry. Can't seem to get rid of it. Right, let's try and grab it. Can't seem to grab it. Can't grab it. Okay, let's try and come out of it. Oh. Alright, now I can grab it. Right, so we've got it there. Is that part of this model? It is. So we need to go through, all the way through, to the other side. So we need to basically push it all the way through. Can we do that? No. Is that because it's not part of this? That's because it's not part of this. So we'll undo the push-pull. We'll grab hold of this. Oh, we still seem to have a line there. Why have we got a line? Oh, there's no line there. Right, so we need to cut that off. Go into this model, make sure I'm all the way in here. Paste in place. Right, so I need to... oh, it's just got two lots. I need to push it all the way through. I don't know if it'll let me do this. I'm going to save it in case it crashes. Push it all the way through. Can I go all the way through? Yeah. Right, so it thinks I've got a... there's still... I've only done half of it. Let me do this. Put it into 2 bits. I'm struggling to get this into the middle of the screen again. Let's do the next bit. Alright. No, still trying to do that one. Alright, so we've got both of it there. So we've pushed it through. Let's... why is it a solid piece? If I pushed it through. It's weird, isn't it? I think I've got to intersect the faces with the model. Let's do that then. Let's intersect the faces with the model. So now we can start deleting. Deleting this. And it's done a weird...
CQ2 meters, M0, PLA mobile, boy for any call.
Alright. Right, we seem to have got a bit... weirdness. Alright, we've got some weirdness going on here. I've got to be careful I don't select the wrong stuff behind. Just do it by bit. Just get rid of all this extra geometry. Don't know what it's doing here, but what we want is a circumference around it so we can remove them, push the material through. Don't ask me why it's made all this. Perhaps I don't know how to do what I'm trying to do. So it's yeah. I know. Just try and find a way of doing it. It's laborious. Right, so we just want the hole that appears. It's horrible. Get in there. Sometimes you have to do this if you don't want to lose other geometry. Alright, what's left on it? There's a few bits. Right, that's cleaned it up, hasn't it? A bit of something going on there. Okay, so we've got that side. And we've got this bit here to get rid of now. Let's just save it as we go. Yeah, it's quite boring this, but anyway. Right, so we've got some bits not quite right. Right, that's not good. Because we need to... Right, I wonder if I can just push that side through. Let's just try pushing this through if it'll let us. No. So can we intersect all this with the model? Let me try it. Without selecting too much other stuff. Yeah, bloody... Don't know why it just won't let you... Even though we're zoomed in on this part, it seems to know about the rest of the model still. Right, so we've got to unselect some stuff. Right, have we unselected? Let's see if there's anything else selected. No, it doesn't look like there's anything else selected. Actually, we could do with getting rid of this hole at the back altogether. How do we do that? Probably just select it like that. Yeah, delete it. Ah. We've got rid of something we didn't want to get rid of now. Let's see if I can repair this. Right, so we've repaired it sort of. Maybe this will be alright as it is then. Do we need that? Yeah, we need that. Right, so yeah, we seem to. Oh, it's got a few rogue pieces here. Okay, so we've got our hole that the laser shines through, and it hits the mirror. What we don't want is the surface here. But it's not interacted, as it? So we need to. Hang on. Can we just say interface the face of the model? Right, now we can delete it. But it needs to be not hollow, it needs to be pushed through, doesn't it? Maybe it is pushed through already. Let's just try it. See how it keeps zooming off the page? I'm just panning like I normally do, but it's I think it's aware of the rest of the model. It's aware of the model. So I can't control it. If I just did that on its own, the rest of the model wouldn't do anything with it. There's no hole there, but never mind. I ain't going to bother to do a hole there. I'm not going to be making this. So it's got the lens on it, so I should be able to see the lens now. But the lens hasn't got colour on both sides. Let's colour the lens. Right, so I'll use the colour from the model. In the model, let's find that one. Must be that one. Yeah. That's the only one we got. Oh, hang on, we got that one. Is that the same? See how it's zoomed off? Yeah, so that's what you see. Your reflection, and yeah, okay. That's it. So we've done that bit somehow. Don't ask me how, we've just done it. Right. Let's put it all back together. Okay, so at least it's anatomically correct. And you should be able to put a beam if you want to make sure. You can put a beam. You can put a beam in here. Find the middle. Tell you what, put a measure from there over to the middle of this one. It should be. So it's not quite lined. See that? Yeah, it's not quite right there. Look at that, slightly out. Okay, so I'll put a temporary mark there. Let's find out which one's out. I'm not sure which one is out. Could be either one. So then we'll put one on here, and we'll come around this way and see if we can't get green on it. No, what's he doing? Oh no, we're gonna have to hard press to get a green on there. So maybe we can do it this way. Is that? Not sure if that's the one. Let's just tilt this a bit, because that could just be picking that up. You have to reference it, then move around, sit over it, and hopefully it'll find it. It's not going to find it, is it? Let's put it there, see what is going on. It looks all weird to me. Yeah, it's not lined up, is it? Not really lined up. Why is that then? Oh yeah. Yeah, it's not lined up. No, it's probably not lined up because that mirror is supposed to be over this side. I thought that, so that one, or I thought that one initially. So I'd have to have a look at the real one, the real mirrors. For some reason they're offset like that. So we'll have to sort that out. Just get rid of those two guides. So there's a little bit of adjustments to do to make them lined up properly. Right, okay. So anyway, we've got that turned around the way I want it. Obviously these aren't fixed down anywhere yet. This isn't fixed anywhere. I've just put it in the middle where it wants moving around a bit. And maybe you turn the whole thing over. I'd have to go and check it. So I'll sort that out after though. But let's sort the case out first. Let's sort the rest of the case out. But I will need a measurement from the top case. Let's hide these angles. Right, have I got angles? Front and back angles, let's hide them. Put the upper back on. Now the upper case, it's already got the clearance it needs. So that's sort of staying where it is, and that's where it comes out of the tube angle hole. That's all anatomically correct, so we can't. I'll leave the top case where it is. Now we need to bring this bottom case up, but we need to work on it as well. So I just need to bring it. Tell you what, I'll bring the case up. I'll put it on the end of that one, so we can measure it. Now, obviously, it's going to have some cutouts. It's going to have some cutouts on it, but the less holes in it, the more the extractor fan can do its job. But we still need the motion. And I also thought about, if we put the bottom back on, we could probably utilise the existing fan. Maybe. Looks like it'll be in the way, but you could put an extractor fan in the back here, basically. Some people put it on the lid, but we'll have to work something out for that. So really, strictly speaking, if this is going to be fastened to there, then this is a waste, isn't it? It's a waste of a strut. So why can't you just bolt that with a spacer to that? But anyway, and the same at the front, it's a waste. It is a waste, isn't it? So you want... Yeah, that's just to give it structure, but if we've got the case there, the case can be the structure, surely. Anyway, we'll keep looking at that. I've got to go and just nip down and measure the case, because I've took something out of this case. So to make sure we've got the right size. And then we do the cutouts. But if we keep the case, we might be able to use the original bed take the stepper motors and everything out and just use the bed. Leave it as the bed, you know what I mean? So all we're trying to do, temporary, like you need a bigger bed ultimately, but just trying to get the gantry to go further around everywhere. Anyway, so it's a bit of modelling to do, so I'm going to nip away and just get a size for that, and I'll do the cutouts. I need to model tube and power supply. Controls can stay where they are with, you know, some nice trunking to be done to. We've got to model the drag chain as well. Get that on there. We know the arc of it, 60mm on the inner diameter, so we can set all those up and just be static. At least we can see where we're going to bolt the ends to, and that. I can put this where it needs to be, but if I move it, the drag chain will stay where it is, and all of that is. But at least we can see. Yeah, at least we can see. So. Yeah, so I need to cut out. So I suppose I could put the cuts in it and just move them down. Yeah, we could do the cuts. So if we're gonna bolt, so the idea was originally to lose the base altogether, or you know, I need a cutout for a pass through. Definitely need a cutout. So the cutout will be where the bed is, and what I've got to work out is the focal distance. I've got to go and take a measurement of the focal distance. As far as I know, there's no way to focus this. That adjustment there, I think it's just for. I think it's just to hold the lens in. So whatever distance it is, it's wherever the bed is. I don't know. I played around with mine, but never gone into detail. Never even took the lens off mine before now, so it's probably dirty anyway. Off the one that I was using originally, which was a well worn out one. Anyway, so if we don't, as I was saying, if we don't do it this way, if we don't bolt this on, then you could probably have an aluminium bracket here, bolt it on and just extend it out and bolt it into the case, into the strut that we're going to sort out, keep it a part of the case. So yeah, there's lots to sort out. Lots of people have had a go at doing this. They've all got different designs. I know what I want from it. I want to be able to cut the whole space here. That would do me, as long as I can cut out the panels for the Amiga case. And I thought about doing an Amiga tower case as well. So put that one on its side. Where is it? Put that one on its side, and it looked very smart on its side on one of the videos. So I'll probably make a tower case version of it at some point. Anyway, so yep, non-adjustable. Silly Goose Dot. Welcome to the live stream, Silly Goose Dot. Non-adjustable. Ah, got you with the laser. Yeah, it's non-adjustable. Yeah. Thanks for that. Thanks for adding that. That will help me save researching it. So I did take a quick measurement while I was down there the other day against the bed, but the bed has been messed with. It's got a piece of grill sticking up, so it's not actually exactly right. But I've seen some adjustable beds. I saw a video earlier where they got some prongs that stick up in each corner, and there's like a stepper motor and a belt with a tension. It goes all the way around, and they just power it up and down off a button. They're not using G-code or anything. They're just powering it up and down. So I could set up a little Arduino to output pulse width modulation, or whatever the stepper motor driver needs, and just up and down it. Some people just do it manually. They put it all in and they just move the belts. Anyway, what do it in stages. We'll do it in stages. But it's good to learn about aligning the mirrors and keeping them clean. And the air assist is vital, really, and then the extraction to get this out of the way quick, get the fumes and that, the smoke out of the way of the laser. Keeping the water. I found out today as well. Or was it last night? I found out that the industrial water chillers, they don't actually do any chilling. They don't. There's no refrigerant in it or anything. There's no way to. There's no actual way to cool down. All it does is it's like a fan in a computer case, and it just takes it down to the ambient temperature. So if you're in a room of 28 degrees or 25 degrees, that's as far as it's going to go down. Maybe a couple of degrees below, but you're never going to get to the ideal 11 degrees for your tube. So yes, it's better than nothing, but so I was about to buy one of those industrial water chillers, but I want to, if it's going to work for me, if it says 11 degrees on the tin, that needs to be, on the label. I want to put it as 11 degrees. I want the temperature to be constantly monitoring the flow rate and the temperature, so I know it's everything's fine. I need to put a camera in there as well. Probably use an ESP32 cam and stream it to a spare tablet or a spare phone or something, or just have it streaming. I've got a lot of tablets and stuff, Windows tablets, Android tablets, old phones. You could just set it in there and stream it wirelessly to a phone or a tablet, and you could, instead of having a lid. And also I've done some research on the plastic lid that they're supposed to be the laser, the amber lid. I haven't got one on mine. I haven't put one in, but there is one on it. But apparently the plastic, there's no way of telling whether the plastic will protect you against the laser beam or not. Whether there's no, with these K40s, there is no documentation to say the plastic protects you against anything. So what you got to do is err on the side of caution, say there is no protection on it. So I'll probably put the camera in and probably get rid of this altogether. Get rid of these any holes or anything coming out of it. So you have to even go so far when I've cut this out, and it has to slide up and down, to go so far as to put some kind of brush strip or something. Some kind of brush strip, like bristles on the end of an alley, that this rustles up and down, but it keeps, you can't see through it. It's just lots of brushes on it. Have to buy. Might have to put one either side, one strip coming up and one down. So the end of the bristles, just the metal just filters through the end of the bristles, but stops the light coming through. So you only got to get a couple of these. There's all sorts of light coming out of this. You have to get the CW5000 if you wish to chill. That's the good to know. Yeah, good to know. Thanks for that. The CW3000 is a non-cooling variant. Yeah, I mean, I've seen people, they've just used a water cooling CPU equipment, radiator and the two fans. But if you're going to do it, you might as well do it right, and you might as well just get it spot on. You need certain things. But I've done something with Arduino. I've done a pressure sensor. I took a pressure sensor and used it on an air spray, a sprayer. What do you call it? Air. I can't remember now. The ones you use for artists, the little compressors. I didn't have a switch on mine, so I made it into I put an analog switch, pressure switch on it, and I set it to go on and off, so I can do stuff with the sensors, no problem. So we can look at the flow rate, get a flow rate analog sensor, feed the reading into a display, and then we can get that to update a lot of this stuff. So I don't actually want a window on it. All I need to do is lift the door up, make sure the piece is where I want it, roughly. Look, I'll just use the camera. If it bounces off the camera lens and destroys the camera, that's only the camera that's got done, and so there's just so much to it. But I want to carry on with this design. So basically, all I'm after here is knowing how much to cut out, how far I can leave in each corner to keep the structure intact. Whether I need this, because it's quite expensive stuff. It's not that much. I paid £76 for 10 lengths of this 2040. It was half price. I bought it at half price, so I've got plenty of it. But if you don't need it, if it's just because there's nothing going to be running along it, yeah, it's great for attaching clips to and stuff, and be able to fasten stuff to it. But if you don't need it, well, you'll have to space these runners. But it is holding all the runners square and everything, so there is that to it. It's holding the runners square. I don't mind using it. But see, the box is about the right size. It's 500mm by like 710. A normal sort of table, IKEA table, is about 600 by about 100 or 120. So if this can sit on there, it doesn't stick out too much, it'll be fine. So if I go from there to there, what you got? You got 550. So this will sit on a IKEA bench with not a problem. Your fan extract, that's the other thing that we need to sort out. Where we can, we want to use the existing one. That's another reason for not having this going across. Depends on how well you can fasten this. Maybe you can do something like, because the wheels won't go all the way up anyway, a piece of this against there to space it out. Let's just see what the spacing is between there and the box. 20.25. So it's almost the same as this, which is 20. It is 20. I'm just looking on an angle though. So you could use a piece of this and just use it there, or you could put just different ways of doing it. So you don't necessarily need this bit anymore, and the front bit. Oh, I'll look at it again. Maybe I've missed something, but yeah, that's why I'm trying to model it all to it, so I can sort of animate it and check it all before. The last thing I want to do is butcher the case up and then find out that I've done a mistake, and I've got to, there's no putting the milk back in the cow, back up the udder sort of thing. Anyway. Right, so I need, I could put this, I could put it in. I'll tell you what I'll do. Let's just hide the top case a minute, and the lids, right, on the angle. So I'll do that. That's about as far as I'm going to get with this, isn't it? If I look at it end on, hang on. I suppose if we put the upper case back, we'd be able to see it better. Look from inside there. Let's come round this angle. Right, yeah, that's about it. We've got what, a few mil spacing between this bracket. Yeah, 5 mil. So that is about it. So from that we can work out how far the wheel carriage is going to come. So if I look at it from sideways on, let's get it sideways on the other way. That's it there. That's in parallel projection. So we can actually find out how much of this we can keep. And it's only the bottom bit we're interested in. Yeah, so I wonder how much CW5000 is compared to the 3000. Because I don't really just want a CPU blower to keep, you know. And the worst thing is a bucket with pipes in. And what happens when the water gets contaminated? How do you clear it out? I don't know. I mean, has it got a tank in it? That 5000, has it got a tank in it? Is there filters in it? Is there a way of refreshing the water? Right, so I'm going to just measure this now. Hopefully I can measure this. We're going to give it a bit of clearance. Right, 42.25. I don't know if that's real. So I'll say, yeah, it probably is actually, yeah. So we want 5mm clearance. So, I'll tell you what, that's not 5mm, is it there? 40mm, so let's say 35. So we'll keep 35mm. And let's see if we can do the back as well, the same at 35mm. What I have to do is just go like this a minute. Take the lid off a minute, up or off. We'll have to move the whole carriage over now to get these sizes. Let's just move the whole carriage over. If I hold the shift, start moving it, hold the shift in, it'll lock it in position. And I know I can't go all the way far back, but I've got to go as far as I can. I'll try it there. Try it there a minute. Let's have a look. I've got to make sure. Yeah, so that's too far back. The motor's touching it there, and I've got to leave enough room for the drag chain. So that's too far back. So let's come back over a bit. Got to leave at least 20mm for the drag chain. Spacing for the drag chain. The back. So let's try that. What we got? 25mm. So right, we'll say 20mm. So I'll come back 5mm. Hang on. What's happened there? I seem to have moved in the wrong direction. Yeah, hang on. Alright, hang on, let's undo that a minute. Let's bring it back. It's come out of the didn't want to do that, so let's do it again. Let's keep it. I've got to keep the green line on it like that. That's it. Keep the green line on it. So we've got to bring it over here. We want about 20mm clearance. Let's say about that. Let's just see. The motor wiring, I'll turn this round and have it facing whichever way is the best way for it. So that's about 20.6. Keep it like that. As long as we can keep our 35mm here. So I'll put the lid back on, the upper lid. Let's measure it across. I think we've got more than enough here. More than enough, I think. Yeah. 35mm there, and we got the 5mm. That's about right then. That's good. So we'll do 35mm again. So we can keep 35mm. Right. So that's where part of our cutout's going to be. Silly goose dot. On the drag chain, make sure it does not cross the path of the laser. I did a miscalculation and mine ended up in the path of the laser. Oops. Yeah, you got to bear so many things in mind. Yeah, so when it bends, you mean when it bends, the drag chain that held the air tube for the nozzle. Yeah, I know what you mean. I've seen someone else. It might have been. I don't know if you did a video of it. I saw a video the other day. They were holding it while they were pushing it. So you're gonna have to do a physical thing on it. But I know my drag chain. It's when you bend it without any pressure, its natural gap in the middle is 60 millimeters. So it's going to need, wherever it's fastened one end and wherever it goes to, it's going to need to be able to arc 60 millimeters. The drag chain will. It shouldn't get in anywhere the lasers because I'm doing it from below. I'm doing it from, if I can. So it'll be going across here, something like here, then up. So it'll be attached to a bracket off the back of the gantry, and then wherever the wiring has to go to. Yeah, so I've got to work that out yet, but the way I've worked it out is I've got to allow enough clearance so this doesn't knock into it. I think they're going to feed it from one end, and this extra stepper motor will be fed. So some kind of bracketry are going to have to go here. I don't know. Got to work that out yet. That bit. It's just taking it a bit of time, but I mean, I've got to bear in mind when I'm designing it to allow for stuff like that. Yeah. So we've got our 35mm there. And let's just have a look where it is opposed to the angle, the tube angle. Let's have a look. So yeah, it can go back another bit. Let's have a look. So another 14mm. So let's get rid of the tube angle. Yeah, so this we've got about, say, 14mm. What has he got here? I think it's about 19.7 according to that. So I wouldn't want to come any further back. So losing control of this now. Yeah, I wouldn't want to come any further back at the minute. Now we don't want to lose any of the spacing. How far down is 50.8mm from your lens? I believe that's the, oh, very helpful. Yes, 50.8mm. We can measure it. Let's just take off the upper case and have a look. So bear in mind this was initially going to go on the floor at this level. So I can measure that to there. Well, I can see where it is from the case, but the case, it might be longer than that might be shorter, this case, because I've cut a piece off it. Right, so if I can measure that down to the bed, that's 148.5. So at 50.8 is about, yeah, so that's might have to come lower there. Yeah, that's a point. I didn't realise that. Yeah, that's about 51 there. So it's about 51 there. So obviously, that part of this is going to get in the way, then, isn't it? That's the focal length. Yeah, so I'm gonna have to have a look at that, if that is the fixed focal. Do you know if they're all fixed focal length, or can you buy something you can adjust? How far? Right, yeah. Yeah, so that's just in the way there. Even if I made the brackets smaller, it's still got these in the way. So, I wonder how they do it then. I've got the original piece here. So that's sort of so flat off the top, isn't it? Right, I see. So I've put mine too high, haven't I? Mine's too high. So no, the reason I put it too high is because it's the way it came out of there. So I'm gonna have to alter this again, I think. Trying to get this carriage to fit underneath to get the extra space. So yeah, thanks for that. That's helped us a bit there. So let's have a look. Let's try to work this out. So I've come through the hole is modelled in the right place, and I've brought it the same height, and I've got a bit more clearance here if I need it. What I've seen, it's like shorter, but it might be wrong. Right, okay. Well, the only thing I've got to go off is an original one, and I can measure that where it is. I've got another one I can get to quickly in the other room. I've got one I've took this part off, a new one I bought. So yeah, I think you're right, because the one I've got here is sort of on that level there. So I can gain a bit of space there, a little bit, not a lot. Let's have a look. 7 mil. So I could gain 5 mil. Let's have a look how far out we are. So we're out by a certain amount, about 8 mil. Well, the bracket can be moved, it's just this bit here. So these, I've left enough space. There is a bit of space on here actually, not a lot. Not a lot of space. Not a lot of space, hang on. It's not really doing, is it? Hang on. 3.5, 3.4. So it's down to the millimetre. Yeah, it's down to the millimetre. So the old Chinese, they were they designed it to a T, didn't they, to get it to work at all, really. You also got that motor to worry about that will allow us crash into the material. Yeah, you're right. You're right. The focal length was a bit of an oversight or undersight, what they call it. Yeah. So I'm glad you came on, and so I wouldn't want to make this and find out that later on. Do you know if you can get a new lens that with adjustable focal length? Because basically, I'm also wondering if you can add another mirror. You know, if you could add another mirror. Because adding an extra mirror that would allow, you know, you can bounce it off more than like 1, 2, 3. So there's 2 mirrors. So you've got to get your focal length below your motor. Yeah. Let me lose the bottom. Let's lose the upper case a minute. Right. So yeah. So we. You can get a longer lens holder where the micro is the same height but the focal lens is lower. Right, might be the answer then, because a lot of people change these out anyway. They're not quite happy with this stuff anyway. But if we can adjust anything now to make it different, So you're constrained with this size of this, where this has to be. You're constrained there. And this is quite thin. The original is very thin, maybe for that reason. And it doesn't go as far. If I can find a link for you, right? Yeah. Okay. Thank you. Yeah. So I mean, I've put plastic, 6mm plastic, just because that's what the one I've got's based on. But we could alter that to be milled out of aluminium. You know, we could gain a bit, but then the motor, unless we rearrange the motor somewhere else. Originally the motor was on top, but then you got this angle in the way. Unless, yeah, trying to keep as much as possible contained. You know, if there's too many problems like this, I might have to do what a lot of people do, is put the laser tube on the back of here. But then you haven't got your contained. You've got to think about safety these days as well. Something like the Cloud Ray K Series Z. Focal length 50.8. Yeah. When you say 50.8, is it adjustable? Is it adjustable? I've seen the Cloud Ray stuff. I think it's a set of is it set of brackets and setup? It's a conversion kit, isn't it? I think it's a conversion kit. Yeah, so that so I have to rethink some of this then. The carriage wheel can go up and down. It's a slit out of the case. So if we do it there, yeah, it's outside the case. Yeah, you've got me there. I don't know what to say about that. And yeah, 'cause this has to stay as it is. The head will place the focus lens lower, but the mirror at the top will remain the same. So the tube, basically this is another mirror. So it's only the tube length you've got to worry about. So as long as that, you can focus the beam further down, but have so basically adjust the size of this here. I haven't taken one of these apart fully. I wonder if you could screw a couple together and get some extra length on it, or you know what I mean, or just buy, yeah, like you say, buy one. If you can buy one, if you can get something that, if you're going to replace the mirrors and that you want an air assist nozzle anyway on it, so maybe that's included. You know, you have to do that, replace it to get your focal length right. Yeah, I'll have to look into that. So do you think I could keep it as it is if I was changing the design? I suppose I ought to open this up really. Let's see what's in it. Let's do that. Let's switch the lights on. It's getting dark. A bit of light. And let's just have a look at this. The camera's changing. So I can screw this off with the lens. Screw that off. I've never really had a look at this yet properly. And that presumably screws off. Oh, it just screws off by hand. Right, never done this. So as far as I can see, there's no more lens in there. So you've just got a hole straight through it, and there's just, it's very basic. So all you need is a longer piece of this, a longer one. Yeah, so you need to get a longer version of that, a longer one, and then your focal length. It'll still be the same focal length, but it'll be lower down. Is that what you're saying? The head will replace the focus length lower, but the mirror at the top, yeah. Yeah, I think you could just change that head and it will be good to go. Yeah, yeah. I bet somebody does one of these, don't they? It's a pity they're not like modular. You could just screw more together. So it looks like we'll probably have to invest in a machine, a miniature machining lathe. Unless I'll have a look, see what we can get. So it's not the end. It's not the end of the world then. That's what you're saying. It can still be done. It can still be done. Yeah. So notice this lens. This lens it's got the flat side facing up, I think. I'm surprised it's not full of smoke, this lens actually. Yeah, it's quite good because my other laser that I've had for ages, I've never took this apart. Never thought about it. I've never cleaned the mirrors, never done anything. I didn't do a whole lot of stuff with it. All I did was create a rubber stamp and tried different things out. Right, okay, that's good to know. So it's just they're just lens holders basically, aren't they? And I don't even think you have to keep the light out. I wouldn't think you'd have to keep the light out. No, because the beam is in free flowing air anyway. So it's infrared, so it's not you haven't got to keep the light out. So effectively, that could be made out of anything, couldn't it? Couldn't that be made out of anything, any kind of tube? As long as you can hold that. So if whatever you could screw that into. Yeah, it's got the angle on it. Yeah, you've got the dead angle on it. So you might be able to make something that fits it, extends it, or buy something. Maybe you can just buy it, or maybe you can just change the head. The price of a head, I don't think it's too expensive. Anyway, we'll keep that in mind. I'll leave. Tell you what, I'll leave that line there. I'll leave that line there, but I'll put it in the middle. Oh, it's gone. Right, I'll leave that line there and I'll make it exactly the right size. So we know it's the focal length. If I can get this to swing round the way I want it. Right, so I don't know where they measure the focal length from, but we'll do it. So it's 50.8, you say? Is that right? 50.8. Yeah. So 50.8. We'll leave it as a line, and we'll colour it. Can we colour that line? I don't know if you can colour it. Yeah, you can colour the line. Let's colour it something bright coloured. Colours, don't know. Bright yellow or something. Amber. Is that too much? Done the wrong thing. No. Oh, maybe it's because it's selected. No, don't seem to be able to colour that. Oh well. Leave it as a line. Right, so I know that's your focal length. It's gone off again. Alright, so we've got our focal length. I'll leave that there with it. And we can work on tailoring the size of this somehow after. It all depends on. Yeah, so we want whatever we want the focal length to be lower than this, at least 10-15 mil below this motor. If we're having a pass through as well. Yeah, so there's that to sort out. When I was looking at it, I was just looking at the wheel carriages mainly. I wasn't focusing on that stuff. Let's have a look. Let's take the bottom case off a minute. Yeah, so I was just looking at the wheel carriages. Well, the height above. Yeah, because originally I had it upright, and I'm just trying to get it to go in. Yeah, I suppose the beam should not touch the tube. It might during aligning when fully operational. Yeah. I don't know. I mean, theoretically, that's just another mirror. So this lens, there's not multiple lenses. That lens could go anywhere down here, really. Why is it in a tube? It's just to hold it square, I suppose, so you can align it up, just to keep it self-contained. I don't know. Maybe just get a longer piece of this extension. Don't know. Would you need it? I mean, this is quite a small, stubby little. I've seen a few. They're quite long, unless it's just the air assist nozzle. I'm not sure. Don't know. Right. Anyway, we know about that now, so we're gonna have to sort something out. But I can try and tailor and get better, size out of this. Wanted to leave a certain amount of clearance, for error. So we've got our front and back markers. They're 35mm. Just put the lower case back on again. So we can hide the uppercase because it's the lower case we're going to be cutting out. So let's do another one this side. 35mm. No, don't want one of them. Same this side. Right. And we know what we want to cut out. So your focal, yeah, we could probably. I don't want to take too much out of this. That angle, see that angle. I mean, we could make them. We could countersink it if we have to. Turn the nut around and countersink it. Have a countersink M5 by 50 bolt instead, and maybe make this out of aluminium. Yeah, aluminium like the original. It's only, I think it's 2mm thick or something. Aluminium. That is just 2mm thick. So there's a reason they do everything. Everything they've done to design it. There's a reason they've done it. Right. So yeah, there's a bit of space to be had here. A little bit of space to be had. I'm trying to keep it like that, but Right. Anyway, let's just carry on. We might be able to sort those kind of problems out. I'm not sure what though, but I wonder what that thread is. If that thread's something, we could maybe buy something that'll do the trick. Right, so let's see if we can sort the case out. So what we've got to work out is how far over the front we can go and out. It's whatever material you want to pass through, isn't it? The width, this bit. I suppose you'd be happy. Let's just choose a size. Hang on. So we can go this way. Well, I tell you what, let's come in 35mm. Let's keep it all 35mm. 35mm. Let's see what size material I could pass through the slot. 642, that's enough really. That's quite a lot. That's probably the size of the cutting area anyway. Yeah. So we'll keep it like that, keep it all the same. I suppose the beam should not touch the tube. Oh, this is another one. It might during aligning when fully operational. Yeah. Yeah. If I'm going to go to this much trouble, I'm going to definitely get some better mirrors and get an air assist one of these with it built in. I'm going to pay a little bit of money. You know, if you know, I don't mind buying some better mirrors than one of these. So, but where I can, if I could make it work with existing stuff, the better, all the better. For now, you know. Right, so let's do some slotting out then. Let's do some slotting out. So I've got it in 2 pieces, but the idea is to cut it. So I've got enough clearance there. I think I allowed 5mm or something. No, 3. What is it? I can't remember what it is now. Let's have a look. From that bit up to the top, 4mm. So let's keep 4mm clearance to the bottom. So we've got 4mm, then 20, then another 4, so 28mm. Right. So there's the slot. 28mm. Right, so 28mm. We'll do one this side as well. Okay, so we can cut out the slot now. Let me just hide the frame a minute. And the gantry. Right. Let's just cut that out. So we can put the lines on it. And just grab hold of this a minute. Obviously, we'll have to move all this. If we start altering the gantry, we'll have to move all this. So I'm going to cut. No, not cut. Oh, I selected the wrong thing. Cut. Paste in place. And just move this down. No, just delete that off there. That's it. And same the other side. I'll have to come out a minute. Whatever space we gain on anything, we'll have to remember to alter all this to match it. We can see it, we can zoom around it and work it out. Right, so we've got our 2 sides. We can have a look at that now. Let's get rid of these lines now. Get rid of the lines we've already dealt with. Okay. Alright, put the gantry back. Put everything else back, the frame. And the gantry. Right, then we can see that we'd miss it. So we'd miss it now, so it can slide up and down there. Put the uppercase back on. So we've got, yes, we've got space where, but if we could put some brush strip across here and below, and this gantry would run in the brush strip. So I wouldn't even cut this then. I wouldn't cut the casing off. I'd just mark it all up and angle grind it, these slots out, and drill all the holes in the right place, all this kind of stuff. So that would be one case still, and the same this side. Now the pass-through, probably the pass-through would be lower. The pass-through would have to be lower, wouldn't it? Wherever the bed is. I need to go away and do some more measurements of the original one. So we'd have a cut out here, front and back. Well, whatever I cut out, I'll keep it. I'll keep the material, keep it neat, cut it out nice and square. I won't be using no jigsaw or anything like that, or Dremel. It'll be done with an angle grinder, but marked up first and cut as fine as I can cut it. I do a lot of cutting in the job, my day job. Sometimes we do lots of cutting. I'm pretty good with the grinder. The slitting disc, so you can slit it out. Obviously file it a little bit as well. Probably put some kind of beading around it so it doesn't scratch anything. And put the thing back, maybe on a hinge, a piano hinge or something. You know, or just take it out altogether and put more brush strip. Probably more brush strips. You just push it straight through the brush strip. Like I say, I have to have a powerful extraction fan, maybe more powerful than normal. Don't know. So we'll leave it. We'll leave that there. We're going to work this the other bit out. So potentially, if I go on to X-ray, you can see what's going on. Tell you what, take these out of the way for a minute. We know it's 35mm. So this gantry at least can be moved up and down the slot. So it can be moved up and down the slot as long as we're on the, I can't see there it is. Where's the green line? Hang on, let's come out of the model and it'll snap. There it is. If I hold the shift in, that's it. So you can move the gantry and it'll just go as far as the slot. So it's in the slot and it'll move up and down that slot. Yeah, so as far I haven't seen anyone who's done it this way before, put it that way. Right. That's probably because it's a mad idea. So the same thing here, so we have brush strip. Okay, so it's sort of fixed where it is. Extractor fan, the existing extractor fan will fit wherever it fit before. Now I'll probably make it with all this on. You definitely want a head that you can focus if you're going to use a pass through. If the material is different heights and such. Yeah, that's true. Yeah, you're true. Yeah. I've never done any experiments with more than one, the lens that come with. I'm just wondering if you can have more than the normal amount of mirrors. So when it's adjustable, is it this tube that's telescopic? Maybe a telescopic tube or adjustable tube. I've not looked too deeply at it. I suppose we could just Google it. Let's just let's bring something up and find out. Right. So a laser head for CO2, adjustable focal length. Right, so there's lots of stuff here. Let's have a look. Yeah, it's got the air assist on it. So that looks like it's adjustable, doesn't it? Cutting edge for. Right, let's just have a look at. Do we have a look at that one? Yeah, let's have a look at that one. Right. So I suppose you just undo that and you pull it out. Just moves the focus lens up and down. Yeah. And the air assist, yeah, that's it. And that's got the adjustable, it's a bit more elaborate, isn't it? Yeah, it's just like a telescopic thing. That's one good thing about it. So it's not the end of the world. It's not like a diode laser where there's all built-in diodes at certain points down its length. Yeah, I like the look of that one. I've got some pipe and joints for that kind of stuff. So that actually fits onto... what's the idea of that then? It fits onto something. Yeah, anyway, that sounds good. See if there's any other ones. Head, lens, tube, air nozzle. Output length, diameter, 20mm. So much stuff about. Focus length, 20 FL. Don't know what this FL38 is. Oh, 63 millimeters to 101. Yeah, so yeah, we'll have to. We'll have to do that, I think, like you say. So I won't worry too much about that at the minute, but good to know about it. Obviously, we've got to make sure. We've got to start somewhere. But what I don't want to do is end up chopping the case in the wrong place. Then having to, once it's chopped, isn't it? Once it's cut, it's cut. So I only want to do this once. I don't want to butcher the thing. It's still got to be presentable, and still got to be good enough to display or use. Right. Okay. Anyway, so yeah, we want to swap that out for an adjustable lens with a CO2 attachment, definitely. We've got to find enough room in it. Enough room for the. I can't see it now. Hang on, let's go into this other mode a minute. Is this any better? So what if I do that? Is that any clearer? Sort of. Yeah, so got to allow enough room. If you have one with the focal length adjusted, we don't have to worry too much about that getting onto the material. We can leave that as it is, and we can put our pass through lower as well. Put our pass through lower. Okay. Yeah, that's it. Right. I lost my train of thought now. I don't know where I got to. Yeah, so it'll still work, but not with that focal length from there. But whether somebody does an adjustable piece that goes in. Imagine if you had some way of adjusting this. I'll have to look at that. Maybe this. I don't know what the thread size is. Let's have a look. Is that thread size anything? Looks like, I don't know what it is, whether it's some kind of known size. You just want, I mean, I could, yeah, I don't think that, no, that's sort of its own thing, it's its own size, isn't it? Yeah, it doesn't seem to be like you can add more of the same on. But yeah, you could probably get someone to make it, or I bet it might be even based on like camera mount technology or something. I've got some camera mounts, haven't I? Let me have a look. Let's see if it's based on anything. What have we got here? Got all sorts of stuff in here. Camera mount technology. What have we got? Got GoPro. Got the GoPro. No, that's too small, that is. What else we got? So much stuff in here. I thought I had one handy. Oh. Right, so I've got the microphone stand. That looks quite big. I don't know if it's anywhere near that. No. Nowhere near that. But then I've even seen adapters that reduce that down in size. I think they use a standard idea. Standard thread or something. Maybe not. Maybe not. Anyway, it's something we can look into. That's something we can definitely look into. It'd be nice to be able to use that as an adjustable one. Or just buy one for what they cost. Buy something. Right, so I need to do some work on it. So this cross member, it's acting as a stabilisation for the sides, and also it's a way we can bolt it to the case at the top. So it's sort of might be necessary. Otherwise, if you take that off and just bolt it with a bracket, you'd have to be very accurate with it, wouldn't it? At least it's holding it all together at the minute. But you could measure from the edges and use the right size, I suppose. There's a lot to it, leveling the bed and all sorts. I don't know if it's as bad as a CNC where you have to level the bed. The laser's got a certain center point, and the focus can move up and down. So between the material, you get aim for the center. It's got a certain ability to cope. Right. So drag chain it was, wasn't it? Drag chain and tube. Well, drag chain, I can model the drag chain. Let's model the drag chain, I think. Let's model a part of the drag chain. Right, and I've got a piece of drag chain down here. Got a nice piece of drag chain here, so I'll just take a link out of it, if it'll come out. It's quite good stuff, this. It doesn't seem to move. It's solid, so I'd have to measure it in situ, maybe. That's the stuff I got, and it's reclaimed stuff, so it's basically the arc's about 60mm if you measure across it. Right, so I could do with taking one out. So let's see if I can get a screwdriver down. Actually, yeah, that one's around the wrong way anyway, that one. Someone's turned it round. I didn't know you could turn them around. That one's locked up in there. Why does that lock like that? Is there... I don't know. Can't see a lot. The light's not good. Right, so that looks like it's the right way, and the other one doesn't. Maybe broken, that one. Right, let's find a screwdriver. Flat screwdriver. Something flat. Right, there's a screwdriver. Let's take one of these links off and see. Oh, that's got its own hole through it. Clever stuff. Right, don't know, let's have a look. Oh yeah, it's coming out. Probably a way of doing it without breaking it. Never done anything with a drag chain before. Never done anything, so I'm just trying to part it without breaking it. Got one piece out, one side of it out. Is that it? At least if I scale it to size, we'll get the exact size of it. Number of links, right, I've got a piece out. Okay, I can model that. Model it, it's clever stuff. Right. Some clever people in this planet. Right, I don't know what's happened to the light today, it's really a bit hopeless in here, the lights. Don't know. Right, let's start by sizing this up. So, what does it look like? So I'll do it sideways on. I'll start with a square. Start with a square, and it's the longest piece on it is 37. 37 by 15. 37 by 15, so we'll do a square. Right, so we'll go 37, 15. And we'll make it into a component straight away so we can zoom into it. Right, there's our piece. And we'll look at it from above. In parallel projection, there it is. Right, we'll work on it like that, and I can then work out everything, every bit of angle and bit on it, bit that sticks up. Right, so diameter of this, well, let's see how far that is in. 7 mil. It's about 7 mil from the end. Right, so 7 mil from the end. We want a bit of a tape measure on here. 7 mil is the centre of the hole, and it's 15 mil, so it's probably 7.5 by 7.5, I'd have thought. But it's got flat on it. Maybe that's wear. Don't know if that's wear or where. It's not new. It's reclaimed. This is. So it's definitely not 7.5. So it's 7. Yeah. Okay. And the hole in the middle. I'm talking to myself really. Yeah, 7.5. So that's halfway down there. Okay, and we've got this hole, which we don't know the size of yet until we get the calipers on it. Alright, let's have a look. 6 mil. 6 mil hole. I'm going to pop off. Hope my insights will help keep you good work. Keep up the good work. Yeah, thank you very much. Silly goose dot. Well, nice one, mate. Thank you for joining the stream and giving us that info. It all helps. It's about time. About time I got some help on some of this stuff. I've been doing a lot of stuff. Little bits of help from people on different projects. But nice. The more the merrier, you know, to help it out. Make it anything to make it easier. Have a good day. Thank you very much. Right, so it's 6 mil. Right, so we've got a 6 mil. Yeah. Right, let's draw the rest of it. Now we've got a line, a step on it. That is 20. That looks like 20 mil, but it's probably 19 mil. So at 19 mil in, we've got a step on it. There, it steps down, then it goes to another hole that steps out, which is 7.5 5, a little bit more off 7.5. 7 point. It's not 8 mil. 7.75. I'd say. Let's just say 7.5. 7.5. There's another hole. And what is the diameter of that one? Right, let's have a look. That's a 6 mil. 6 mil pin as well. Okay, so that's it. It's probably slightly less, but we'll say it's 6 mil. 6 mil. Right, so that one sticks up, and the other one's got a hole through it. Now what we need to do is, we've got a step in it. There's a step down in it. It looks like, is it 2 mil? Is that 2 mil? Can't tell. I suppose we can just measure the width of it. Let's use the calipers where I can. Right, so we've got 12, 13 mil, and on the outside of the other one we've got the depth. We don't need the depth of that yet, but 16.5 mil and 12.83. 12.83. Okay. Right, so I'll sort that out. So, let's get the shape right first. We'll get the shape of it first. So I've got a weird cutout here. Right. Let's arc the. It's not even a proper arc, unless this is a worn out bit. It's hard to see. Let's just have a look at the rest of it, see if they're all the same. Yeah, they're all the same. They've got a flat on them. They've got a bit of a flat, so let's measure that. Starts to the flatten bit. Sort of talking to myself here, sorry. So 4 mil. So if I do 4 mil, 4 mil and 4 mil. So we've got a flat, so I have to do 4 mil again. So we've got an arc that goes from there to there. I've lost it. Where's he gone? Hang on. I should have pressed the button then. Yeah, so we've got that. We've got a flat. It looks a bit too severe, that flat, actually. It's not quite as bad as that, but could be. We'll keep it like that for now. It doesn't have to be exact. We're not going to make this. We're not going to make it. We're just going to model it. As long as it fits together and it's the right size. Right, so I've got another arc around this. Alright, it's difficult to work out. So it's whatever that distance is again. Yeah, so we'll put another arc around it. Right, whatever this distance is here. No, that's the wrong thing. Wrong tool. Right, so that's 450. So if I put a temporary thing of 450 around it. Right, that gives us our bend. I don't want to delete all that though, do we? I want to break it, but not all of it. How do I? Can't explode it. I'll tell you what, let's put a temporary line in it. That should allow us to select. No. Another temporary line. Hopefully I can just select, yeah, half of it and get rid of it. And get rid of that now. So it just helped us out a bit. Right, then we've got this flat area with an angle off it. Right, so we can get rid of, that's our total length, and it sets half a bit. So from the centre it goes up a mil. Yeah, up a mil, and is that a mil? 2 mil. Right, so let's say a mil and a half, 1.5, and we have a line that comes from this point here. Oh no, it goes from 1.5 up, and then it'll come up to just above level with this bit, sort of slightly higher, about there. Right, so we've got that there. That looks about right, yeah. Then we've got another bit down. It comes from the centre to it's about 4 mil. 4 mil, 3.5 mil. So 3.5 mil from this bit. There's another bit of a gap. Is it 90 degree? It is 90 degree actually. Yeah, it's 90 degree. So what we want is a line from there up to there like that, and we get rid of this bit. Okay, and then we go off on a straight flat. That's flat, so just go straight out. It doesn't go all the way, but we'll put it all the way for now. Then we've got, let's measure from there across. So it looks like 4 mil. So if we go from there, from this bit here, 4 millimeters. Right, is that right? It doesn't look right. No, that's not right. What happened? So from there to there is 4 millimeters. It must be more than 4 millimeters. Let me have another look. Right, so it's quite hard to see. 4.5 millimeters. Let's do it again. 4.5. Right, okay, so according to that, it goes up like that. That does look about right actually. Okay, so we can lose that. We can lose that. And this. And we can also lose that. No, don't lose that yet. Wait, what happened there? Are we not? We're not quite jointed up there. Look at that. Don't know why we didn't quite get. What happened to that? How come? That's weird. Let's just draw that again. Probably didn't do it to there. I stopped a bit short, didn't I? So it needs to go to there like that. So I messed it up a bit. Which means I've messed a lot of it up. Hang on. Let's get rid of some of this stuff a minute. Over to right to there. I need to do a better line, a better one. Okay, we need to get rid of this. We need to get rid of this and that, and also that and that. So that is supposed to be look something like this now. Yeah. So that's what we got. Weird shape, sort of. Right. So get rid of some geometry. The good thing is we can snap it all together. Copy and paste them and snap it together. Get rid of that and that. This one here, that's the step in it, so we do need a line down there. That's it, and we can get rid of that bit of geometry now. Let's get rid of that. So that's what we've got so far. Now we will have to give it some thickness. So the thickness is, do you know what, use the calipers. 1.5 mil. It's 1.5 mil thickness. And to get alright, so I'm gonna have to temporary get rid of this a minute. Temporary cut it off. So we can turn it on its side. I need perspective on for this. I need to make it 1.5 mil thick. 1.5 thick. And we need to paste in place the existing geometry. And then we can... Oh, so what we've got to do is... Hang on, we need to just take that off a minute. That can stay probably. Yeah, just leave that on. Cut it. Paste it in place. Cut it. Go back into the model and paste it in place. I should be able to now push that through. Now this one goes up. But not yet. The whole thing has to be stepped down first. Let's see how far it's got to be stepped down. Well, it's probably going to be 1.5 mil, isn't it? Yeah. Same again. So we've got to somehow push this whole thing. Now there is a piece of extra stuff in it. Yeah, so if we if I just draw around it like that. Lost it now, has he gone? Draw around it like that, and back around the other side. Right, we should be able to now splice it. So we've got to splice it, we've got to move this whole thing, this whole piece, down by 1.5 mil. It'll probably try and pull everything on it. Yeah. So what we've got to do is cut it. We can sort that out back again. No, I'll tell you what we will do. We won't cut it. So I can select all these faces. Oops. We want to copy it, that's right. Copy it. Yeah, so first we want to copy it. I've like losing my... see how it's wobbling all over the place. Right, so we're going to copy it. Copy that bit. Right, we're going to paste it somewhere like this for now. Right, then we're gonna group it. Group that and get rid of this bit now. Hang on, be careful I don't. Yeah, it's okay. Just get rid of this bit. And then move these lines off, keeping the rest intact. And I'll group this one as well. I'll push this one, grab this one back again and push it up to the corner there, like that. Right, what have I done with it? There it is. It's gone. Can't get the geometry. That's it. Right, so we like that. So what's different about it? So it is stepped right there, but then there's a bit of plastic holding it all together, and the plastic's got sort of angles on it and all sorts. Very clever stuff. Right, so what we'll do, keep it the same way up, and we need a reflection of that the same again, certain distance apart. Let's see how far apart it is. Looks like it's 10 mil. 10 mil, is that 10 mil? Maybe slightly less. Let's try and find one that's exactly the right amount. Or we'll use the calipers again. Use the calipers. Alright, switch it on. Let's have a look what it is. 9.93. 10. It's 10 mil. Let's just say it's 10 mil. Right. 10 mil. So what we're going to do is we're going to copy this now. Copy both of these. I'll tell you what. That could probably stay as it is. Yeah, once it's like that. Oh no, we've got to push that up now. Now, is that flush with that? Nearly, not quite. Not quite as high. So we said that was 1.5. So we're going to say that is 1.25. So we're going to push this up. If I can get it. No, why isn't it looking at it? Oh, it's a group, that's why. Push that up by 1.25. Right, so we look at it end on, it's slightly lower than the, yeah, that's it. Right, so that's that bit done. So I think we'll explode both of these now. Right, we've come right out of it, don't want to do that. So we want to copy this. So we'll copy it, and it's 10 mil lower, so we're going to copy it down by 10 mil, and we need to flip it. So it needs to flip along. I don't know if it's the blue direction or the, I don't know. Is that it? Needs to be the same. Yeah, that's it. The blue direction. Yeah, these need to be the same as each other. Okay, that's good. Good so far. Right, let's just try to grab hold of it. Oh, I don't want the paint box. I want that one. I'm trying to control it because we've got a great big model in the background. It's trying to force us to spin around that as well, even though we don't need it. Right, so I need to join it up now with these. There's a bigger section on the back than there is on top. So that one's sort of in line with the bottom of the hole. Is it exactly? Oh, hang on. No, it's not exactly. Almost exactly. Alright, so we start. If I can get the hole lined out, so let's bring tape measure from the bottom of this hole across here, and It's not quite lined up, it's a little bit higher. So if we come down there and move across just a bit, it's not even 0.25, say 0.25. Yeah, so we could start from there. Let's just make sure we've got 10 mil between these two. No, we've got 7. So let's just bring that one down, another 3 mil. Now we should have 10 mil, yeah. Okay, so now we can draw a line from here down to there. That's our one line. These two can go now. So can that line. Okay, and we've got to come over. Hang on, that's the. Am I doing the right? No, I'm doing the wrong side here. I've done the wrong side, so that line. I need to move that line over. That's the wrong line. Needs to go on the back. So, it's just the easiest way is to find out the width of that. 15 mil. So grab it and move it in this direction. Where's the direction? It's not letting me do it from that angle. Let's just move around like that. That's sticking with it. It's not going to let me go with it. Yeah, okay, so well, crazy. Well, what we'll do is we'll have to draw a line from here up over to there and down the other side, and then we'll have to grab the line by the top, and then still not letting us move. Okay, so we'll cut it, spin round. I'll just have to paste it. And we're holding it by the bottom end now for some reason. Hang on. Let's get it from there. Put it down here. That's it. That's crazy, I know. Right, let's get rid of these two. So we've got the back of it. And we've got to go over now to... It's just above the other line, the other hole. Just above by about, what we're looking at? 1 mil. So we need a line from the bottom of it, like that, and then 1 mil. Is it 1 mil too much? No, it's about right. 1 mil. Yeah, let's say is it 1 mil? Maybe. Right. Okay. Just make sure that line was in the centre. It was, wasn't it? Was it? Yeah. Don't know. Need to look it from above. Yeah, it is. So that's the right line. So we want a line now from here down to there. Okay, get rid of these. Get rid of them. So we've got our infill, the one side. We can give it a thickness. So it's got, just trying to see it. Yeah, it's got like a ramp up to the middle, and a sharp ramp and a long ramp. So the sharp ramp is about 3 mil. 4 mil, say 3 mil. Let's turn it round. So I'll tell you what we'll do. We'll bring. Can I just bring that up? It's 1.5 by the looks of it in the middle, so we'll bring the whole thing up by 1.5 mil. Let's make sure we haven't got a hollow. No, we haven't got a hollow, we're okay. I need to shift it round to work on this side. So we need say a 3 mil. I could measure it, I suppose. It's difficult to get in there. 3 mil, maybe. Let's just say 3.5 mil. So we'll draw a line. Okay. Let's save this, by the way. Let's save it. And at the back, just after there, it's how it starts ramping down. Oh yeah, it just comes in a bit, doesn't it? So it ramps down about, looks like about 8 mil. I can't see it, the light is very poor. What's going on with these lights today? They just seem really poor. Let's just say 7.5 mil. 7.5 mil from here. 7.5. Let's draw another line. Just make sure that ramp is in with that slot. Yeah, it's about, yeah, it is, it's about that. It's almost exactly that. Right, let's put a line there. Alright, so we've got a bit of a ramp to put on it, so we've got to come down to almost a point. Almost a point. Right, let's get rid of these lines. So I've got to manipulate this round now. I'll try it. I don't know if it'll let us grab and move the point down. Let's see if we can grab that line. It needs to go down. No, it's not going down that way. I need to manipulate this round. I can't seem to twist it. I'll tell you what we'll do. We'll just move the whole thing round flat while we work on it. Right, it's not doing it, is it? Right, so let's come out of it a minute. Right, now we can turn it round to work on it. Right, we can work on it now. Right, so I just need to pull that down a bit. Ah, why are we still? Why have I selected all that? No. Why are these in blue? That's weird. That's the weirdest thing I've ever seen. Why is that selected? It's got to be an error, isn't it? Yeah, it's gone now. It's just a glitch. Right, it's a bit of a glitch. Right, let's just bring this down to a sharp point. Right, let's bring that down. Will it let us go down? Let's like just tell it which direction. That's it. A little bit more to quite a sharp point. Let's zoom in a bit. It's come down 1 mil, so let's say 1.25. That'll do. Right, that's alright, that side. Let's go around the back and do the other one. And we can colour it in a minute. Alright, let's bring that down by... Hang on. It's not knowing which way I'm going. Okay, that's done it this time, 1.25. Right. Okay, so that's our piece. We've done the one side, but not the other. So why haven't we got the top? Oh, we probably haven't done that bit yet. No, we've done the one side. We haven't done the other. So we're making a drag chain interlock, whatever, section, link, which they should all link together and make us a drag chain. Let's do the top bit then. Let's just save it. Scale, it's scale model. So give or take, human error. Alright, so this one, we can measure the kink. Right, so from the kink up, it looks like 2.5 mil. Yeah. Is it 2.5 mil? Yeah, 2.5 mil. So we want a line. So back into this. A line 2.5 mil up here. Right, so there's going to be a line there. Okay, and we're back the other way from the kink. 7 mil. Is it 7 mil? Yeah, 7 mil. So we want to go this way. 7 mil. Draw a line. Okay, so that's our other bit of the kink. Now it's just got a ramp on it. It has, hasn't it? Yeah, that's got a ramp too. So that ramp is about 3 mil and 3 mil, is it? Yeah, 3 mil and 3 mil. So let's go around the other side. Right. So I suppose you could use this to create a 3D print, make your own drag chain, maybe. Right. So is it the same thickness? Yeah, it's all 1.5 mil. So we go 3 mil in and 3 mil in. Draw a line. And drag them down again by the same amount. No, so what's happening? Hang on. No, it's not liking that. So let's try a different. That's better. So 1.25. Right, that's done now. Go around the other side. I don't know what's the matter with this program. It depends on where you are or where about you are orientated. Depends on which key you have to press. That worked out. 1.25. That's it. Okay, so we've got a bit of a weird ramp going on. No, have I used the wrong one? Why have I got an extra line there? Don't know why I got an extra line. Let's just undo it a minute. Undo, move. Undo, move. No, that's right. Oh, I know what I've done. Redo, move. Redo, move. Now it's bent it round the wrong bit, hasn't it? Does it matter? Yeah, undo, move. It's not bending it round this bit. Ah, I know why. I know why. Just got to put those links in there. Alright, that's it. Now it'll do we need that bit there? Why have we got that bit there then? Oh, that's the one I put in. Yeah, we don't need that now. Will it still do it? Should do, shouldn't it? Yeah, should do. Should be able to just get... I've lost the track of it now. Should be able to do it without that one there, maybe. Alright, let's just do this last bit. Then colour it and put the chains together. Just press the left arrow and come down. What's going on over there? 1.25. Oh, it's okay. I thought it was corrupting something then. So we've got that. Oh, it's not done it, has it? Sorry. No, what I should have done. What happened? Don't know what happened then. Hang on, undo move. Oh, it still put the line in. Didn't want to bend it where I put it, did it? Okay, so it's just got to be there then. Right, undo erase, undo, draw a line, undo, draw a line. It's just putting it where it wants to put it, so. Right, we'll just keep it there then. I'm not that bothered. About 0.25 of a mil. Um, 1.25, that's it. Right, okay. My eyes aren't that good to distinguish 0.25 of a mil in the bad light, so it's not absolutely. It's close, but yeah, no cigar. Right, okay, so we've got this thing now. I need to colour it once we took some of this geometry off it. Just some of this construction geometry off it. It shouldn't matter, none of this should matter. As long as the surfaces are contained, we've made it into one now. Right, what else have we got to get rid of? Anything else? Yeah, some more this side. Okay, so we made it into one piece now. Any other abnormal geometries? Something weird there going on, isn't there? 2 dots. Right, so there's some lines there in the. Some of my original lines, don't know why. Don't need them. Okay, anything else? Any other weird stuff? Yeah, there's some more lines there. Okay, any more? Any more weirdness? Yeah, there's a line there we don't need. Don't need that one, do we? Any more? Any more lines? No. I think that's about it, isn't it? Is that it? Yeah, I think that's it. Everything else is needed, I think. Yeah. Although we have got a bit of weirdness going on here. Because we've got nothing there, no meat between that. So let's have a look at what goes on here. Ah, right, hang on. There must be an overlap somewhere. Ah, there's a ramp. It's ramped actually, it's not bang on, it's ramped. So we need to sort that out. We'll sort that out now. There's a ramp on it. So instead of just having a line like this, you've got a ramp. So what we'll do is we'll have to ramp it. Probably to that size there. So if I do that to there, then I copy that one, copy that and do another one down here. Then draw a line from there to there. That's the ramp. And we want the same one this side actually. Same one this side. So let's just do a copy. So we copy it. Copy and paste. We need to flip it. Flip along. Is it the green direction? I don't know. No. Alright, let's try again. I never remember what direction it is. Flip along the red. Yeah. No. No, not quite. Not quite. Undo. Flip along the blue. That's it. We'll just put that. We'll zoom around here. Oops. Put it there like that. That's it. That's the one. It hasn't filled it. Here's me losing control of it again. So I'll just take one edge off. Put the edge back. That's it. So we've got it all back now. Yeah, we've got it all back. We've got our final piece of the puzzle. Right. So I just need to... Yeah, that's it really. Right, let's just colour it black then. We'll have it synthetic surface. This colour's normally pretty good for black. Yeah, it's pretty good. Pretty good normally for this colour. Right. Alright. Right, is that it? No, there's always a bit more. Just when you think it was safe to come out of the water. There's a bit of a weird line there. Don't know what that is. Graphic glitch. It's almost like you can see through it, but you can't. Yeah, it's just a SketchUp glitch. Right, okay, that's about it, I think, for that. Right, let's come out of it. It's a component already, isn't it? Yeah, it's already... Oh, no. Oh, yeah, it is a component. Right, let's save it. Right, let's see if we can hook a few together and see what happens. Let's hook a few together. Got a bit of a weird thing there, isn't it? I'll tell you what, we have got that though. It is square like that. So what's causing this glitch? Right, seem to have a bit of a glitch because that's probably because it's no thickness. I don't know what I can do about that. Probably not a lot. Anyway, we'll leave that. Right, so I'll join the two together. Let's copy. All we've got to do is find out the distance between the centre of this and the centre of this. 19.5. 19.5 it is, yeah. Right. Tell you what we'll do, we'll just measure that on the real one, see if it is 19.5. As far as we can tell, 20.35. Alright, so we've got that there. It's about 20 mil. It's 20 mil, so we're a little bit out here. I think we're a little bit out. Let's have a look. Right, so we're a little bit out. Let's measure it from this bend. 19.5, we're a little bit out somewhere. So what can we do about that? We can compromise a bit. Go into this. Just grab that like that. Move it, move the one out. 0.25. And this one the same. And make sure you don't grab the wrong geometry.
M7GJB requesting radio check.
0.25 there. Right, so I should have now. Yeah, 20 mil.
Did you say airport? Sorry, you're coming over crystal clear and what have you like. I'm just trying out a new antenna I've just chucked up today. So my location's in Cannock, Staffordshire.
Yeah, so we've got to do the same with this one.
Oh, try going up too, I suppose. See if you're there.
So make sure I haven't selected anything else, doesn't look like it.
525.
Okay, so we're alright now. That's a bit better. Right. Let's just see if we got 15 mil here. 16 mil. Why have I got 16 mil? Hang on. Right, so across the top of the widest piece. What we got? 16.66 across the smallest piece. 12.9. $13, so that's close enough on that one. And this one we're a little bit out, so we need to 16.6 7. Right, so okay, we'll compromise a bit. We'll just make this one go up 0.25. This one down 0.25. No, that went funny, didn't it? Hang on. No, did it go funny or not? No, it's the way I'm looking at it. So that's okay. So redo and redo. That's it. No, it does look weird. What? No, it's not right. Look at that. See it? Something went wrong there. Hang on. It was one of my earlier moves, I think. Yeah, There it is. It's one of that earlier move. It went in the wrong direction. So I'll tell you what we'll do then. We'll make it a little bit easier for ourselves. What we'll do is we'll just we'll leave the holes where they are. And so we'll grab it like that. Let's see what we've grabbed in here. Yeah. We'll grab it like that and we'll... Oh, the overall size is right though, isn't it? No, we can't do it like that. Right, let's just do it like we did it before. Actually, it's grabbed both holes, so that's okay. So go across this way, 0.25. It's better, probably better if you do it in parallel projection mode, but go across this way, 0.25. Make sure it's still good, yeah, and then we've got to widen it by 0.25. 0.25, and this bit here 0.25. Let's have a quick look around it. Nothing too bad has happened to it now. Okay, that's a bit better now. Let's just measure it. Give it the last bit of measuring. Make sure if I can get hold of it again. Right, so we've got from there to there 16.5, from there to there 13, and from the middle of this one to middle of this one, if I can get it, 20.25. Not really. Let's go from that one to that one. Oh, it is 0.25 too much. Why is that then? But my one hole is slower than the other hole, so what we'll have to do is measure it from the centre of there to the centre of there, but we'll have to come up a bit to there. 2.25. It is slightly too much. So which one are we going to alter? I think the back one. These back two. Come this way. 0.25. That's it. Right. Okay. That's it. We're done. We're done. Right. So let's join them together. Join them together. I should just join together. So if I grab this one like that and just move it, copy it and move it 20 mil. Is that going to do it? Yeah. Yeah, so it snaps into place. Oh, does it? Hang on. Is that right? No, it's not quite right, look. That one is. I couldn't have selected something. Right, undo, copy. One of these is wrong. Right, hang on then. One's wrong. I think it's this one. It's a trouble when you've got to select just the one you're after. And make sure you haven't got nothing else. See, I've got that selected, look. Right. It's difficult to do. Alright, let's try and select just that. Without anything else selected. Yeah, I think I've done it. So, I think I've got to move it this way. 0.25. Let's just measure from there to... Yeah. Okay, so now if I copy one of these over, 20mm, it should be in the right place. It is that side, and it is that side. Okay, so tell you what we'll do, we'll put another one of them over there. So we'll copy that and move it over 40mm. Right, and that should have sat in that hole there as well. Yeah, it did. Yeah. Okay, so we've got a bit of a drag chain. Now, you can articulate it. Which way does it articulate? Obviously it doesn't articulate that way anymore. Should they even be together, them two? Let me have a look at a real piece. Doesn't articulate much. Hang on. Let's find a bit. No, there is a gap. There's definitely that gap there, so begs the question, what stops it moving then? What stops it moving? I can't tell. Can't tell, it must be the bit inside it, yeah. This is the bit that stops it moving. It's the, so that gap is right there. So let's try and look inside it to see, we can see how it works. So that looks like that hits the bottom here. Let's go into 3D X-ray and we'll move one of the pieces. Which one should we move? This end bit. So we can grab hold of that one and articulate it from the middle here like that, and so we're trying to move it up like that, so that's how far you can get it. And what stops it coming down? It's actually touching, yeah, so it's touching the middle bit there when it's down, so it can't go, but can only go up. Clever stuff. Oh no, no, I'm not articulating it right, am I? What's going on here? No, hang on, scratch that. Let's get hold of the thing right. Hang on. Right, let's put that there, so that's got to go into there. Yeah, that's better. That's better. Hang on, what's going wrong? Oh, so that the top holds it there, and you're allowed to go to there. Yeah. This angle's not the best. I don't know if can I move the angle? I should be able to move the angle so I can see it and go back on here. Yeah, and carry on. Yeah, so it hits the plastic just there where that is there. And when it comes down, the top hits the top, so it holds it straight. Yeah, there's not much to it really. It's clever. Right. So if we have enough of this on here, if we have enough length on it, we should be able to articulate it and find out its maximum inner circle dimension. Alright, let's put another bit on. Let's just select 1, 2, 3, 4. 1, 2, 3. So let's copy the 3. So we've got to move it up. What do we move it up? 60mm? I don't know what it is now. Can't remember. Crap at maths. So 20, 40, 60. Yeah, 60mm. So we'll copy that and move it over 60mm. Right, and then we'll do times 10. Right, there we go. So we've got a bit of drag chain now. It looks like a bicycle chain a bit now. Right, so we've got a bit of drag chain. Now we could do a circle. Yeah, we could need to do a circle on it. So what we're going to have to do is work out the angle. Yeah, we need to work out the angle of this. Right, that should be easy enough to work the angle out of that, shouldn't it? Right, let's just try and work the angle out of that. So we start from here. Go like that. So go like that, and then just... Oh, no, we don't want to do that. We want to measure the angle. I think you do it off this one, actually. Do it off that one. I can't work out how to measure it now. So start from there. It doesn't show the angle. I need a measurement. Have I got a measurement tool? Yeah, is that it? Where's the angle? Oh, 26.9. Right, so it's 20.
Calling and listening by Mike 0 PVM. Just wondering if anybody else is listening in, please. Wonder if you want QSY to 425. So
right, so the angle is
QSY 425.
26.9. So we'll start off midway. Right, we'll start off midway. So we'll just get this. Hold it in the center, go like that, and then move it up. Oh no, we can't move. We need to join them up, don't we? We need to select more than one. Yeah, so we'll have to select without selecting the case. So if we do it, so if we select all them and change the angle. Oh, it's doing it anyway. It's already gone to 26.9 for some reason. Right, then we'll have to lose.
Okay, nothing. Monitoring 425. QSY 425.
I'll have to lose that one and then move the rest by. What was it again? 26.25. It's not snapping to it this time. 22. I can't remember what it was now. I can't remember what it was. That's a pity my memory's rubbish. Okay, so I'll just try this again. We'll have to measure it again, won't we? So start off. Oh, we can't do it from there. Let's go to a different. Oh god, I'm useless. Can't remember basic things like numbers. Right, let's try and measure it. So if we go, it doesn't know where it is it? Right, I'll have to undo rotate, just so I can go and measure this angle again. $26.9. Okay. Redo rotate. So we've lost one there, so now we need to do another one. I need to go 26.9, I believe it was. So then we need to lose another one. Am I going in the right direction? Hang on. Am I going the wrong way? I'm going the wrong way. I'm going the wrong way. Dear me. Right, okay, so we'll grab that and grab that. I'm bending it the wrong way, so 26.9. No, that can't be right, can it? Can't be right. No, that can't be right. I must have been going the right way. I don't get it. Undo array. Redo array. Redo flat script. Redo rotate. Right, so it's lost all that. Okay, let's try it again then. So select all that. Right, so we've got that there. So you need to look inside it. Which way do you... Oh, so it swings up. I was going the right way. I was going the right way. So 26.9. And I lose this one and go to the next one. 26.9. Okay, lose that one and go to the next one. 26.9. Lose that one and go to the next one. 26.9. Lose that one and go to the next one. So hopefully when we finish this, we'll have an inner dimension of 26.60 mil clearance. Hopefully, or something has gone wrong. Okay, lose that one. Oh right, we've gone a bit wild there. What's happened? Alright, so where have we got 60 mil here? 68 mil, yeah, okay. So that last one, we don't need to do that. Sort of, we just need to go straight. Okay, so I'll go... Just bring it straight. Oh, we can't bring it straight. What have I done? Grab hold of that. So we just need to go wherever that one is and bring it down straight. Like that. Doesn't look quite right. Oh, yeah, it is just perspective of it. So we should have something like 60 mil here. 69 mil. Okay. In reality, we've got something like... What have we got? Let's have a look, see what we've got here. It's difficult to look at it in without bending it, so just hold it naturally. We've got 60 mil. So we've got 8 mil more arc than we should have. Why is that? Discrepancy in the design slightly? Don't know. See how they're overlapping there? Not quite right. Anyway, it's close enough for a model just to see. So to get this to be 68, it doesn't matter. 8 mil gives us a bit of play. It probably does matter. Probably matters quite a lot actually. So we either alter the model slightly to get the degree we want, or let's just put it somewhere. Let's see what it looks like. We're upside down anyway. Yeah, it doesn't look, looks weird there, the way it sticks up. Might be my angle's not quite right. It's not exactly, I can't even see what I'm doing, and the light's rubbish in here. Anyway, so let's put that somewhere. Let's put that somewhere here. So, initially was we're going to do... Let's alter it round a bit. Let's do it like... Where's the axis? No? What's going on? Oh, I need to turn it around 90 degrees. That's it. And bring that up here, somewhere like this. It's not having it, is it? Hang on. It's probably going to go the other way, actually. So it starts from this corner and then bends back. Right, so can I flip it? Yeah, flip it and then bring it out. Stuck inside the thing. Alright, so I've got something like it. I've got to work out how it's going to get attached to something as well. It's going to have to stick out. Yeah, we've got something to work out there. Anyway, a little bit of progress done. I'm going to go for an interim. How long been going? 2 or 3 hours. That's probably enough, isn't it? And I'll go and take some measurements off the height and different stuff. I think we'll call it quits there today. We've done a drag chain, we've put a slot out, altered this a bit. Yeah, that's going to be it for today. Maybe I'll carry on. What time we got? Oh, it's 10 o'clock at night. Yeah, that's going to be it for tonight. Back on tomorrow night. So, thanks for watching, and let's get the thumbnail ready for the next one. Yeah, it doesn't make no sense the way it is at the minute. It's going to have to come... It's going to have to be attached to something there at the top of here, I would have thought. Out the way of all this. Unless we put it down below. I'd rather it was attached up here. Let's just grab that from there. Just put it up here or something. Put it anywhere like that just so it's out the way for a minute. Let's grab it. Grab it and somehow just put it like that and bring it out. Bring it out this way. 10mm. See what we got. Not saying it's going to go there, but it's got to go somewhere to start with. It's probably good as place as any. Yeah, it's not that bad. It's not bad actually. I'll have to have a bigger bolt or something, or another fastening point somewhere. So it needs to be fastened somewhere. There needs to be some kind of angle or bolt through there. Yeah, so it'll have to be bolted through, and the cables come. Don't know. It's yet to be worked out. Yet to be worked out. So for now, we could just repeat that. Let's see if we can work it out. That'll do for now. Then the inside one we'll sort out another day. Yeah, we'll make bigger chains. So to animate, it's gonna have to stay where it is. I can't get that to animate. I can, but it's complicated, and It's not worth. It's not worth. It's just so we can get the position right. That's all that's for. Where we're going to put this bit. Alright, that's going to be it for today. We'll leave it at that. What about a 3D view? Let's have a look at the 3D view. Yeah, probably something like that. No, makes it worse. Don't know. No, we'll leave it on non-3D view. Okay, that'll be probably next thumbnail. I'll catch you all tomorrow night. Thanks for watching. I'm out of here. Bye bye. Let's have some noises.
The most logical course of action is to transport me to safety with all due urgency.
This constitutes all available data. That information is not available.
Then you will remain silent until further instructed.
Confirmed.
If you didn't want the answer, you shouldn't have asked the question.
Borak, what are your limits?
They have not yet been defined. My knowledge is virtually infinite. My secondary ability is to logically process that knowledge and make accurate predictions. Instructions are not needed if commands are succinct. That is better. Our relationship will be best served if your statements are free of ambiguity.
You know what they say. No good deed goes unpunished.
My interpretation of the data leaves little room for error.